Ever find yourself wondering just how those algorithms seem to know us so well? Like, when your streaming service suggests a movie and it turns out to be something you absolutely love. Or how about when your navigation app predicts your commute time with, like, spooky accuracy?
It really is quite fascinating how much these predictive models have kind of become a part of everything, wouldn't you say? I mean, from those weather forecasts we rely on to even like stock market analysis, it seems folks are always looking to algorithms for a peek into the future.
You're telling me.
Yeah.
But it's always kind of bothered me. It's like, how do we actually know if any of these predictions are actually any good? I mean, anyone can throw out a guess, but how do we really measure the accuracy, especially when we're talking about something as complex as, let's say, the stock market?
And that's what we're diving into today, right?
Yeah.
You found us a really interesting article all about this thing called mean squared error, or, MSE for short, if you want to sound fancy. You can think of it kind of like a yardstick for checking how accurate predictions really are.
Okay, I'm listening. Got to be honest. But before we get in too deep, can we maybe like break down exactly what MSE is? I'm picturing like some big scary math equation with Greek letters and all that.
Yeah, let's leave those Greek letters for the textbooks for now. Imagine for a sec you're trying to predict, say, your commute time each morning. Some days you're spot on, right? Other days, well, you're off by a couple minutes. And then there's that one day where, who knows, a flock of sheep throws everything off.
Oh, tell me about it. I've been there. Those sheep.
Exactly. Now, MSC, what it does is it calculates, on average, just how far off your predictions were from those actual commute times.
Okay, I'm with you so far. But I have a feeling it's not just a matter of like adding up those differences and calling
Yeah,
it a
you
day.
got it. It's a bit more than just simple addition here. Let's say you thought your commute would be 30 minutes, but it ends up taking you 35. That's a 5-minute error.
Ouch. Happens to the best of us.
Now, instead of just noting down that 5-minute difference with MSE, we square it. So that little 5-minute error becomes 25.
No, hold on. I got to ask. Why are we squaring those errors? It seems a bit, I don't know, extreme, don't you think?
Think of it this way. Imagine a dartboard. Hitting that bullseye, that's a pretty small error, wouldn't you say? But then, there's being way off in the outer rings. That's a big miss. Squaring those larger errors basically amplifies their
Okay,
impact.
I see what you mean. So by squaring the errors, it's almost like MSE saying, hey, those big misses, we're going to pay extra attention to those.
You got it. And it's this focus on those larger errors that makes MSE so valuable, really. It lets us understand just how far off our predictions could be, especially, when we're talking about those high-stakes situations where a tiny error can make a huge difference.
So MSE is like that strict teacher who gives more weight to, those big blunders on an exam. It's not enough to just get the right answer. You're to be consistently close.
That's a great way to put it. And just like a tough teacher, MSE pushes us to develop models that are more accurate, more reliable, the best they can be.
So this MSE thing sounds like a pretty big deal for, well, anyone making predictions, really. But where does it actually, like, come into play in the real world? The article you sent mentioned it's used everywhere.
Oh, it really is. Think about like predicting house prices for a minute. That's a massive market with tons of factors at play.
No kidding. You've got location, size, all those like fancy kitchen upgrades everyone's talking about these days. It all adds up.
Exactly. And that's where our friend MSE steps in. Say a real estate company is using some fancy model to try to predict those prices based on, like you said, all those factors. MSE basically lets them see how well their model actually stacks up against the real deal, those actual market prices.
Because if their model's way off, people could be making some pretty expensive mistakes.
Exactly. A high MSE in that situation. Huge red flag. Means the model's predictions are, well, let's just say they're not exactly winning any accuracy awards.
Yeah, you definitely don't want a high MSE when you're messing with something as important as people's homes. What about like other places? Where else does this MSE thing play a critical role?
Well, you might be surprised to learn that MSE even pops up in something like image processing.
Wait, really? Image processing? I
Yeah.
never would have put, like, statistics and image editing together in the same sentence.
Believe it. Imagine you're trying to, I don't know, improve the quality of a blurry image. Algorithms can actually use MSE to compare that original blurry picture with the enhanced version, pixel by pixel. And the lower the MSE, the closer that enhanced image is to the original, meaning, boom, you've got yourself a clearer, sharper picture.
Wow, that's kind of wild. So even those silly filters we're all using on social media are secretly relying on MSE behind the scenes.
You got it. And it doesn't stop there. Oh, no. The article even mentioned financial modeling, which I'm sure you can imagine involves some pretty high stakes.
Yeah, I'd imagine those financial analysts aren't exactly messing around with high MSEs.
Not if they want to stay in business, that's for sure. In finance, MSE is like super important for analyzing the accuracy of those risk models. The ones trying to predict how much money a bank could potentially lose. A high MSE there could be the difference between a sound investment strategy and, well, utter chaos.
It's like they say, with great predictions come great responsibility.
Something like that.
Speaking of responsibility, let's be real for a sec. No model is perfect, right? I mean, are there any limitations to using MSE that we should probably keep in mind?
That's a great question. And you're right, perfection is a myth, especially when it comes to models. One of the big limitations of MSE is how it can be, influenced by what we call outliers. Remember those sheep that totally messed up your
Right.
commute?
Yeah, those sheep. Good times.
Well, that's actually a perfect example of an outlier. It's like a data point that's way outside the norm totally throws things off.
Okay, so let's say we're tracking those commute times again. Imagine one day there's this massive traffic jam because, I don't know, someone decided to film a car chase scene on the highway during rush hour.
Happens more than you think, actually. But you're making a good point. That traffic jam, that's your outlier, right? It's going to mess with your average commute time. And because MSE squares those errors, that outlier's impact gets amplified even more. Could make your model look way worse than it actually is, even if it's doing a decent job overall.
So it's like what, judging a whole class of, like, well-behaved students based on that one kid who just chugged a gallon of soda. Not exactly fair.
Exactly. And that's why it's super important to remember MSE, a powerful tool, no doubt, but it's just one piece of the puzzle. Shouldn't be the only thing you look at when you're evaluating predictions.
Context is key. Now, I did notice the article mentioned something called RMSE, root mean squared error. Is that like just MSE with a fancy new name, or is there something more to it?
It's definitely more than just a name change. Think of RMSE like, I don't know, the cooler, more approachable cousin of MSE. They're related, for sure. But RMSE gives us a slightly different angle on those errors.
Okay, color me intrigued. Tell me more about this cool cousin.
Well, you know how MSE squares those errors? RMSE takes things a step further, finds the square root of that whole thing, like, taking the edge off a bit.
Right, right. But why even bother with the whole square root thing?
Because, get this, RMSE gives us the error in the same units as our original data. Remember those commute times? MSE would give us that error in, like, squared minutes, which, let's be honest, is kind of hard to wrap your head around in real life.
Squared minutes. Makes my brain hurt just thinking about it.
Right. So RMSE cuts through the confusion. It brings that error back down to earth, gives us a number that actually makes sense in the context of our data. So if your RMSE is, say, 5, you know your predictions are, on average, off by 5 minutes.
Ah, see, now that makes a lot more sense. It's like translating from some foreign language back to our native tongue.
Exactly. It makes those insights way more useful, way more relatable to those everyday experiences we're all familiar with.
Okay, I think this whole MSE and RMSE thing is starting to click for me. But how about we walk through an actual calculation just to really make sure it sticks? I'm a hands-on learner. What can I say?
I'm all about hands-on learning. Talking about the formula is one thing, but seeing it with actual numbers, now that's what makes it real. And lucky for us, the article actually gave us a nice little example we can use.
Perfect. Let's dive in and see if we can channel our inner statisticians here. All right, so we've got these sample commute times, right, and the predictions to go with them. Let's see. For the actual times, we've got 10 minutes, 20, 30, 40, and 50. A whole work week.
Nice. Even spread there. And what did our fancy prediction model come up with?
It predicted 12 minutes, 18, 32, 38, and 48. So, some days are closer than others. How do we actually take those numbers and turn them into that MSE thing?
Remember, it's all about the difference between what actually happened and what we predicted would happen, right? So first things first, we got to find each individual error. Like for that first day, we've got 12 minutes predicted minus the 10 minutes it actually took, giving us an error of, you guessed it, 2 minutes.
And then we just do that same thing for each day, right? So that's, let me see, 2, 2, 2, 2, and another 2. Wow, oddly consistent, I gotta say.
Don't let it fool ya. Remember the next step. Got to square each of those differences. Amplify the impact of those big ol' errors. So 2 squared, that gives us 4, and we just do that for all 5 errors. 4, 4, 4, 4, and 4. Even more consistent, I'd say.
Right, right. I remember this part. So now we add up all those squared errors, right?
Uh,
4 plus 4 plus 4, and you get the idea. Gives us a grand total of 20.
See, you're a natural at this. And the last step to get that MSE of ours is to divide that sum, that 20, by the total number of data points, which we know is 5 because we had 5 commute times.
Okay, so 20 divided by 5, bod, boom. That gives us an MSE of 4. But for what exactly? Like 4 squared minutes of error.
Nailed it. Remember, MSE is all about the average of those squared errors, so even its units get squared. Squared minutes might sound kind of weird, I'll grant you that, but it's really just a way to compare different models when you're looking at the same data. Smaller MSE basically means the model's predictions were closer to the actual, real-life values.
Right, right. So lower MSE is like getting a gold star on our prediction test. But what about that RMSE? If I'm remembering right, that one actually uses the original unit, so we'd get an answer in, like, actual minutes, not squared minutes.
Okay, you're on a roll today. To get that RMSE, all we got to do is take the square root of the MSE, which we already figured out is 4, and the square root of 4, that's a nice even 2. So our RMSE is 2 minutes.
So basically that means our model's predictions were, on average, off by about 2 minutes. Not too bad, I'd say.
Not good at all, and way easier to understand than those squared minutes, wouldn't you say? RMSE just gives us a better, more practical sense of how accurate our commute time predictions actually are.
This has been, like, seriously eye-opening. We went from, like, how do algorithms even work, to diving into the nitty-gritty of this whole MSE and RMSE thing.
Yeah.
But before we call it a wrap, what's the main takeaway for everyone listening? Why should they care about any of this?
Think about it every single day. You're bombarded with predictions, weather forecasts, those stock market tickers, even those, sometimes creepy targeted ads that seem to know you better than you know yourself. All of those driven by models, my friend. And now you've got the inside scoop on how to figure out how accurate those models really are.
It's like we've got a secret decoder ring for the world of predictions now.
Exactly. You can look at those predictions with a whole new perspective now. You can start asking the right questions, like how accurate is this thing likely to be, or what might be throwing off these results. Understanding MSE and RMSE, it's like having a backstage pass to see how these predictions are really made.
So next time you're, I don't know, checking the weather app or maybe scrolling through those eerily personalized recommendations, remember this deep dive. There's a whole lot of data crunching going on behind the scenes. And now, well, now you're in on the secret.